A jet is flying with an airspeed of 480 miles per hour at the bearing of north 82 degrees east. Because of the wind, the ground speed of the plane is 518 miles per hour at a bearing of 79 degrees east of north. What are the speed and direction of the wind? Okay, so there's a lot going on here. We've got wind, we've got jet, we've got ground speed. So the ultimate conceptual piece to this problem is we know our ground speed vector is going to equal our wind speed vector plus our air speed, right? So in order to find my wind vector is going to be my ground speed vector minus my air speed vector. So keep that in mind, because the ground speed is being affected by the wind's force on the air speed. So to find the wind, I subtract the air speed from the ground speed. All right. Now with that said, I'm going to create a couple vectors, one for ground speed, one for air speed. So if I think about my ground, so let's say my air speed first. Airspeed of 480 miles per hour at 82 degrees east of west. And this is going 480 miles per hour. So I can draw a right triangle. If this is 82, 90 minus 82 is 8 degrees. So in order to find the x and y components of this airspeed vector, I need to do some trig. So my hypotenuse is 480. So the x component is going to be 480 cosine 8 degrees. And the y component is going to be 480 sine 8 degrees. And that's because cosine of 8 is x over 480 and sine of 8 is y over 480. So I skip those steps. So let's see. 480 multiplied by cosine of 8 is approximately 475.3, and 480 times sine of 8 is approximately 66.8. So that is my airspeed vector. So now, in order to find my ground speed vector, I'm going to do another sketch. And we could have put these together in one sketch, but it would have been, I think, more confusing than helpful. So my ground speed is 518 miles per hour, and it's bearing 79 degrees east of north. So 90 minus 79 means that this angle right here is 11 degrees. I can create my right triangle, once again finding the components of my ground speed vector. It's going to be 518 cosine 11, 518 sine 11. So 518 cos 11 is approximately 508.5. 518 sine 11 is approximately 98.8 degrees, 98.8. So these are the component forms for my air speed and ground speed. So remember, the wind equals ground minus air. So my wind vector is going to equal my ground, which is 508.5 and 98.8 vector, minus My airspeed, 475.3, 66.8. So let's see. My wind vector is now 5.5 minus 475.3, 33.2, and then 98.8 minus 66.8, and 32. So that is the component form for my wind, but I needed to find the direction and speed of that vector. So let's think about it. 33.2, and 32 is going to be in this positive quadrant. So this is 33.2, this is 32. So I need to find out the magnitude and the direction. So first, the magnitude is pretty easy. We can just do the Pythagorean theorem to find the length of this vector. So the magnitude of my wind is the square root of 32 squared plus 33.2 squared, which is approximately, let's see, 32 squared plus 33.2 squared, 46.1. And so that's going to be the speed, 46.1 miles per hour. Now we need to figure out the direction. So I'm going to start by finding this angle. So this angle is found by doing tangent inverse of opposite over adjacent. So tangent inverse of opposite over adjacent means that this angle is approximately 44 degrees. So if this angle is approximately 44, I can subtract that from 180 to find that this angle is 46. So the direction is north, and then we go 46 degrees east of that north. So this is our final answer. The magnitude is our speed, 46 miles per hour, at a direction of north 46 degrees east. So this was a very involved problem.